So let's go through differentiation. I want you to think of differentiation as simply finding the gradient function. And you would have seen maybe earlier that if you have 2 points on a line, let's say x1, y1, and x2, y2, any 2 points, the gradient is simply y2 minus y1 over x2 minus x1, or rather the change in y over the change in x. So these 2 points is simply we're finding the rise over the run. Okay, so let's say you had a function that was f of x equals x cubed. Okay, so f of x equals x cubed, and if we maybe plotted, maybe we say x squared, just simplify it. It would be positive function, and it would look, this is a really bad drawing, but maybe look something like this. Okay, I don't know what it looks like. Let's say we even simplify even more. Let's just say f equals x. So it's just a straight line through the center. So to find the gradient function of any line, we're going to use the formula dy over dx, which is a gradient function, equals n times x to the power of n minus 1, where, let's say we have in this function, n equals the coefficient. So then that's literally it, n is just the coefficient. So then if you had this in this case, it would be 1 times x to the power of 1 minus 1, which will just equal 1 times x to the power of 0, which is just 1. And I'm just going to go through a bunch of examples now. I understand how, like, there's not really much context, so there's another method called differentiation via the first principle that I'm going to go through next, but that's a bit more complex, so this is just kind of the easy method. So let's say you had f of x equals x cubed plus 4x squared plus 6x plus 6. So a really long, weird function. Actually, it's just a cubic function, isn't it? So dy over dx, which is just basically the notation for the derivative, the gradient function, is going to equal, and if I just write the formula here again, n times x to the power minus 1, it's going to equal 3 times x to the power of 3 minus 1 plus 2 times 4x to the power of 1 plus 6 times what plus 1 times 6 x to the power of 1 minus 1. And then if we think of that, 6 is 6x0 plus 0, because 0 times anything is just going to equal 0, which is quite important. So if you have any kind of constant value, whenever you find the derivative, you're just going to completely ignore it, because it is essentially like if you had 5, that's 5x to the power of 0, because anything to the power of 0 is 1, so 5 times 1 is 5. So then this is just going to be, I'm running out of ink on my pen, let me grab another pen. It's going to be 3x squared plus 8x plus 6. That's going to be your dy over dx.